This is Neil Schneider for MTBS-TV at CES 2020. To my immediate right is Steve Venuti. He's Vice President of Marketing for a company called Keyssa. Welcome to the program, Steve.
Thank you. Good to see you again, Neil.
Again, yes, because the last time I saw you, it was a couple of years ago, but you were President of HDMI, as I recall.
That's right, the legacy connector, as they said. So now I'm on to newer and advanced technologies.
Yes. So, well, why don't we talk a little bit about Keyssa? So what do you guys do?
So Keyssa is in the connector business, just like HDMI was, but we see metal and mechanical connectors as a major problem for product designers and engineers. So what we've come up with is a solid-state connector.
Okay, so why don't we talk a little bit about the challenges of a traditional connector, so, metal connectors, like why are they a problem?
Well, any consumer will tell you they're a problem because they're the number one reliability issue. They break, they wear and tear, they get water in them, lint, dust, and so forth. That's one major problem. The other problem is signal integrity. Signals are getting faster and faster. Metal is a natural radiator of energy. They start to conflict with Wi-Fi, Bluetooth, they run into each other. That's a major product design issue. So many issues. And the biggest issue is industrial designers just don't want connectors, and neither do consumers. So we're moving towards a world where everything is wireless. We think the connector should be wireless as well.
Okay, wonderful. So now you have a solid state connector. Can you elaborate a little bit more as to what that means?
So solid state really means, and I'll show this, maybe you can show that. And
I took a picture, but it's tiny. There's a little tiny chip in here, but go ahead, Steve.
Well, that's what it is. It's a piece of silicon. So no mechanical parts. You still bring products together. You come in and connect them by bringing them in close proximity. They line up and they automatically connect, and then they can transfer data at very high data rates.
So when you say high data rates, how high?
Each of these little 3x3 millimeter square pieces of silicon can do 6 gigabits per second, and you can add them multiple lanes to be able to get more bandwidth. We have implementations up to 100, even one that's over 600 gigabits per second of transmit wirelessly.
So it's not just that we have an efficient way of transmitting data, like you're not using metal, so it's small. So what are the applications that are introduced because this connector is so small?
So anywhere where you have two devices coming together that need to connect. So we have an implementation on an LG phone that is a dual screen. So the second screen connects to the main phone via our technology. Docking is a perfect example. So I have a tablet here from Fujitsu, just launched. This docking tablet goes into a dock, and now the connector, the exposed pogo pins that used to do the connectivity were a problem, environmental problems, getting all sorts of things on them, getting gummed up and not working. They use our technology. Other things like video walls, where products come together to form huge video walls, where connectors, there's massive number of connectors. That's where connectors are a problem as well. We're in those as well.
Now, I know that for this version, the smallest version, it's 6 gigabytes of throughput, but I understand that could be expanded. Can you elaborate a little more?
So each of these, consider these a lane. Consider them almost like a pair of wires. And if you add more pairs, you get more bandwidth. So if you add more of our devices next to each other, and since they're going a very small distance, we're not trying to go far, they're very directional, they don't interfere with each other, just separate them by a little bit, and then you have additional lanes of connectivity. So you can add 6 to 12 to 18 to 24. As I said, we have implementations up to 600 gigabits per second.
Okay, good stuff. Now, how close do these connectors have to be to work?
So they'll be in close proximity, which we consider about chip to chip, about a centimeter. So it really is think of it as a tablet in a dock, a video wall, two LED panels coming together. We're not trying to go too far in distance, because then you're no longer a connector. Then you're starting to be Wi-Fi or other connections, network connections, and which are wonderful, but then you have higher power, higher latency, higher cost, security issues. So it's really 1 centimeter chip to chip, which really means kind of products touching each other.
Okay, good stuff. So do you think that this technology, it's not just about connecting the circuitry and the signals, do you think is it introducing new opportunities that perhaps couldn't be around before? Like, I'll use the LG phone as an example. Like, why was this connector so important for the LG phone?
You put your finger on a very important part of the reason why people use this technology. It allows them to design products in new ways. So the LG phone, they really had a difficult time with two screens next to each other with mechanical connectors. This allowed them to free them up to think about new ways to connect two devices and even create new devices.
All right, good stuff. Now, you're holding a tablet in your hands. Why is this tablet so important?
Well, I just saw it. That's one reason why it's important. It's a new implementation of our technology from Fujitsu, a docking tablet. Sorry, I don't know if you can see it. It's a docking tablet, so no different than many other tablets out there, but this is used in commercial applications where environmental hazards have a deleterious effect on the connector. Connectors are going out, pogo pins were going out just because of things in the air and things getting on them. So they went to a wireless solution with our technology. They can dock this, and they have no problems with the signal integrity or the mechanical aspect of a connector.
All right, good stuff. So this sounds like it's a major innovation in connecting electronics.
Well, we think so. We think I/O generally, which is a fundamental, every compute product has to have I/O. We think it's been neglected. It continues to be a very old technology. Mechanical connectors are very old technology. And so we're bringing advanced connectivity to I/O and to connectors in the way you transmit data.
All right, good stuff. Thanks so much for joining us, Steve.
Thank you very much.
This is Neil Schneider for MTBS-TV at CES 2020. We, of course, will be back with more. Thank you for watching.